On this episode of the show, I have with me Karan Talati. He is co-founder and CEO at First Resonance, and we're going to be talking about manufacturing and some of the complexity that goes into it. Obviously, hardware businesses are a little bit different. We'll talk about some of what has and has not happened, and we'll talk about industrialization and effects on national security, where things have gone wrong potentially, and the fact that companies have tried to save a couple bucks and potentially put themselves behind the eight ball. We'll have a couple of areas, hopefully we'll get to. Karan, I don't know if we'll get to it all, but we'll certainly try.
Great. I'm excited to be here, Amir.
Absolutely. All right, before we start, what does First Residence do?
So at First Resonance, we build the world's leading factory operating system. It's powering now nearly 70 companies in complex industries such as aerospace, defense, energy, maritime autonomy, and more. It's a software platform that helps the very complex set of engineering that goes on in the factory, everything from manufacturing engineering to quality engineering to even some levels of supply chain, orchestrate all that information to get moved through the factory and then get a great piece of hardware on the other side of the factory.
Okay, I love it. I guess before we dive in, and maybe this sets a baseline because a lot of people, especially on even for me on the show, I deal with a lot of software. When we start dealing with hardware, and we're talking about a factory operating system, and we're talking about manufacturing, talk to us a little bit. Maybe the top level of, is this something that companies just do not currently have? Like, is modernization of manufacturing that far behind? And is this where technology comes in and gives us opportunities to create things that potentially have been too expensive in the past?
Yeah, it's a little bit of all that. So let me break down, where the industry is today. So about 30, 40 years ago, when, kind of compute revolution was happening, we did get the emergence of this category called MES, manufacturing execution systems. And those systems are there. They're, deployed at factories, far fewer than one might imagine. Only 15% of factories in the United States have a manufacturing execution system. Others are using paper and pen, and very ad hoc systems. Now, companies that are more at the edge, a little bit more recent, new kind of companies, they're using generic workflow management systems, right? So they'll have a Kanban board in Jira or like a Trello board, Asana, or something like that. So then there's this like messy middle of like, where are we at? We, on the one hand, have a very legacy, big MES systems that runs on your local data center that only 15% of factories have in the United States. And the other hand, you have paper and pen, and then you have general workflow management systems. So as we get into the 2020s, and there's this huge proliferation of deep tech, hard tech, and modern aerospace and energy companies emerging, they're kind of lost in between all of these, and that's where we enter. And now, all of a sudden, with cloud and open APIs, you actually can deploy purpose-built software in a price point that's affordable enough. Even though affordability is not the key value prop, it is important. It doesn't cost an arm and a leg. You don't need to have your own data centers to do this. That's where we find ourselves filling the gap.
Absolutely. I love that, and I think we don't talk a lot about manufacturing. Obviously, I think a lot of the glory of technology goes to the software side. When you're looking at this modernization, I guess two things within that. One, it would strike me if we're lowering costs that it's also then hand in hand with what we're seeing in robotics. We're lowering cost of manufacturing in general. So it's giving us and giving smaller startups a more even footing compared to traditional large R&D manufacturing where they have those facilities to test things easier or come up with an idea and see if they'd want to actually explore it versus a startup having to spend a lot of money just to get off the ground to get to a starting point.
Yeah, that's right. And, that's a very important thing in today's zeitgeist with the need for modern energy solutions. As you know, so that's one example in energy. The needs of an evolved battlefield. So modern defense tech companies getting involved because the kind of battlefield has shifted from big kind of fighter jet capabilities into more miniaturized drone and electronic warfare types of technologies, right? So it's important to empower those early players that are very, very quickly iterating. So startups, as one might say. But the other interesting nuance of manufacturing is that, like I mentioned earlier, only 15% of manufacturers in the United States have an MES system, manufacturing execution system. So the rest of those 85%, these are not all startups. Some of these companies have been operating for 30, 40, 50 years, some even longer. But because of the technology divide, right? Because of their inability to access large systems. And, they might be a shop that has been building a critical valve for aviation for the last 30 years. Maybe there's 50 people, maybe there's 500 people. They don't have these systems. So there's so much area for this modernization of technology to fill in, enable the startups on the one side, and also enable companies that have been working at this problem set for 50 years. They've just been doing it very manually, very brute force, and very under resourced.
I guess we've heard a lot in the last maybe year, 18 months, depending whenever you're hearing this episode, about manufacturing coming back to America and that it's been offshored extensively. I mean, I'd have to say there's very few things that I buy that are manufactured here, unless it's a very small maker of something. Talk to us a little bit about that dynamic of what we've seen transpire. Obviously, we'll get to the manufacturer coming back to the States potentially, but let's talk about it being exported for now.
Yeah. So, there's a lot, as you said, Amir, there's a lot of conversation right now about reindustrialization, the importance to reshore and onshore and all of that. But it's also important to, have a really good perspective on that history. So I'll dive into it. And by no means is the podcast to go into the history of industrial policy. But it is more relevant than ever. So 30, 40 years ago, there was a group of people, and as the internet was kind of coming in, it made sense to offshore manufacturing, as we were in the post World War II era, and the capabilities were there at a lower cost point in Asia, particularly. That the promise seemed reasonable, actually, if you look at it now. Go move some of this very dangerous and rote labor offshore to a lower cost point, and thereby giving Americans, cheaper products, therefore a better standard of living, and more ability to spend time in the kind of design, development, and services industry. Right, again, also increasing standard of living. So that's the world we've been all living in, for most of us in the last 30, 40 years, to your point, Amir, like it's a little bit, one doesn't pick up something physical and assume that it was built in a factory in their town or even in the United States. The assumption is that it came from elsewhere. The problem, and this is why this conversation has opened up, is over those 30, 40 years, we went from, yes, good idea, let's build this cup somewhere else, into the entire supply chain of advanced electronics and even some of these critical components going into defense hardware, microchips, things like that. All of a sudden, we blink as a society and look around and say, "Wait, you're telling me that microchip that's required for this fighter jet or that tank, we might not be able to get if the geopolitics change." And that was a huge rude awakening. That's where we're at today. We're in this rude awakening of these geopolitical shifts. Some of what used to be our partners in manufacturing all of a sudden have amassed so much strength in their industrial capabilities, which has brought up their economies. And now the decks have been reshuffled to the point where people are rightfully asking those questions. So it's like, oh, what happens if we don't have access to that capability? What happens when we don't have access to being able to manufacture advanced optics, right? Well, not only do you lose your tanks and your fighter jets, you might lose your self-driving cars. You might lose your AR glasses. You might lose cell phones, right? And modern mobile devices. And, these things are so powerful now. They even have lidars on them, right, for various purposes. So people are asking that question, and manufacturing is a lot more important. It is not just a side topic; it is front and center to the world that we live in, and all that is at risk because the world is changing, right? And so we could talk about more about like what we need to do now, but hopefully it's a helpful kind of lesson of how we got here.
No, absolutely. I think that's a great talking point. And, I think the overview you provided was very pertinent to what we're seeing. I guess when we're looking at that, and you mentioned how few companies actually have systems in place, and obviously, if we've been outsourcing these various components to places where uh, not that they're being produced maybe necessarily cheaper. I won't make that assumption for everything, but it's just not being produced here. And we're looking at the gap of companies that just haven't had to manufacture. If you're looking at that gap, obviously it probably represents opportunity for first residents. But when you're looking at that gap and that know-how, bringing some of that technology, that know-how back, obviously I get you need the software systems. It where's what else has to shift in terms of mindset so that
Mm,
you'd want some of the manufacturing, because I don't know if we want it all. I don't know if we necessarily need
yeah.
my mug to be made here. Like it's not to national security, but the stuff that has to come back, what has to start shifting from a mindset for companies to start being able to actually get to a point where, and it's going to take time. It's not like, this is not a snap of the finger and next
Hmm.
week we're back up and running.
Hmm. Yeah, so Amir, you actually said something there that is very important to this conversation. And interestingly enough, in our world, at First Resonance, we do sit at the intersection of technology, of policy, of financial markets, right? So it can get kind of tricky, right? We don't have the luxury of simply just innovating and making money, right? We do have to grapple with some of these questions. So the thing that you had mentioned there that I think is very important is we don't need all of manufacturing to come back. We shouldn't, in fact, have all of manufacturing come back. How are we going to make these super important microchips if we're also spending time building these mugs, right? So um, I think one has to have a very nuanced perspective of like what are the layers of manufacturing that really allow you to build um, the high value components that are important to national security and are better off being built near shore for various reasons. Again, because of the defense side, geopolitics, as well as costs. Some things are actually better to build near because of the transportation and logistics and how that market is changing. So, in order to get that right, one, we have to have a nuanced view on the layers of manufacturing that result in finished goods and a higher standard of living and a better economy. That's one. And the foundation of that, this is number two, beyond software. And I think software is just one piece of it. We focus on it a lot at First Resonance, but I think way more important than that is the workforce. And for that, that is also a policy kind of question is how do we reskill people into serving these manufacturing jobs, which can be a lot of fun and are highly technical, very high skilled, and actually some of these very high paying. Very interesting. Some people don't know when you're flying, at the airport and you look out and you see some of these aircraft technicians. These are not low wage or low skilled jobs. These are highly skilled jobs, and they are six figure types of jobs. So there's a big opportunity of reskilling people into those types of work streams. Especially when we're bringing back things like semiconductor manufacturing into the United States. Again, very high skilled, very highly technical, and very high paying. So I think I'm very passionate about this. It's not an area that we go after with full force at First Resonance. We want to put the right software and tools into that workforce's hands so that they could operate with sanity when they come to work every day and they can leverage the power of big data and agentic workflows. That's all great for us. But the core of this is for us, even at First Resonance, It doesn't help if you have all this great software if you don't have the people who need to use that software to make these things happen. So I think that's another big aspect of what needs to shift is the workforce and how we approach it as a society and as individuals, making sure that people have the information to know that these are highly technical, fun, and highly paying jobs.
Absolutely. That's actually very well put, and I agree with you. I guess a question. I had somebody on as a previous guest, and we were talking about material manufacturing and innovation, and how there's really no way of observing results consistently because there's a lot of disconnected systems. And obviously, if you can develop a potential horizontally integrated solution, you can then see the results as you're going. You could see what's happening. You can make decisions. You could use AI to actually help you simulate XYZ. When you're looking at manufacturing, I guess maybe this ties into a little bit about what you guys do. When you're talking about this, supporting the entire factory, and I guess from an innovation standpoint, it's just going to be a lot more data. I'm assuming you're going to see more things, and this is where, with that data, potentially is AI sitting someplace to help us with that innovation. I guess help us understand when we're talking about modernizing a factory, we're getting more data. What does that opportunity look like for companies who are trying to develop these hardware components?
hmm Yeah, well, it's a great question. And I think you said a key word in there that's important to it, and that's the horizontal layer, right? So, historically in manufacturing, because of the bigness of these systems and because they've been so underpenetrated in factories, which we talked about earlier, um, only the uh, only the companies with sufficient capital and focus and force are able to actually integrate these work streams from engineering to the actual manufacturing operations to in-field operations, not to mention the financial stack and materials and procurement layer and supply chain layer and everything like that. All of a sudden now, with the democratization of this technology and the cloud, you can connect it now at a much more rapid clip. And of course, manufacturing coming in, it makes it more useful to actually do that. So now, that layer is coming up very rapidly. There's a modern stack of a lot of what used to be done very manually in a very disconnected way, like the modern kind of like reshuffle of PLM and simulation software, manufacturing software, such as what we do at First Resonance, test and measurement software. And to your point, Amir, with AI can actually help accelerate the systems integration here just from a developer perspective. Understanding the documentation across all these complex interfaces is now much more accessible, and developers can more easily connect these systems, right, and program that in. Of course, I think over the next year or 2 years, what we're going to see as well is a lot more agentic operation where AI agents are, somewhat autonomously or semi-autonomously actually making those decisions of, oh, this information can be useful in manufacturing. So imagine a design engineer updates a CAD model. And for those who don't know, this is really what the upstream design is doing, what the product is going to look like. Imagine a world where the world that we live in today, where an engineer makes a design change and a manufacturing engineer doesn't know about the design change for weeks, if not months. Now imagine a world where an autonomous AI agent actually just serves as somewhat of a co-pilot and lets the manufacturing engineer know, hey, there's a design change that might affect the process that you're laying out for the actual manufacturer of that camera system, for example. We live in that world now all of a sudden. Now this technology is still very much, like I would say, 0.5% penetrated. But over the next, a few months, years, we're going to see this go from 0.5% to 1% to 10% to, 50 to 100, right? Where these autonomous AI agents are basically keeping people informed in the factory and in the field of what changes are happening. And that's one last thing. Imagine a world where understanding how hardware is operating out there in the field, we could actually go inform the design of that product. We could go inform the manufacturing of that product and update its material properties, updates the processes that we're building these hardware products in, so that when those products get out into the field, They are more reliable. They might be more efficient from both the cost perspective as well as weight and fuel and energy perspective. That loop we could build now with the cloud technology, with AI agents, actually augmenting that decision making, and so on and so forth. This is, and this is inspired off of the technology, definitely. One thing I'll mention in here as well is this is also at First Residence inspired by our experience. So I, as well as members of our team, spent years at SpaceX with a lot of resources to help us with this problem. But nevertheless, applied the technology of what's now available to everyone else, closing these loops across design, across manufacturing, and then across operations, particularly being able to land the Falcon 9 rocket, learn about how the rocket operated from launch and then landing, and then feed all that data back into the factory and back into the design. That was the aha moment. That's really what opened up my eyes to, wow, like we did this. And now we could do it for people that are building modern nuclear reactors or new types of maritime autonomous technology, and this entire world that we're going into. We're very excited about that.
I, I love that. Maybe a final question. I mean, we're still early with AI and we're seeing so many moving parts. And it feels like most of those parts have a a hardware component to it, right? The more we talk about AI and how great it can be for us, the more it seems that there's a power shortage, electricity. We need more data centers. We know, I mean, literally buildings. We need the chips. We need so much hardware. Whereas maybe I don't know when a similar parallel would be to history when we needed so much hardware than we do now. Because for, as you said, for like 20 years with the cloud, no one wanted anything. We just had all this, everything beamed down to our mobile phone and we're happy and we're ignorant about
Mm-hmm.
everything else. When we're looking at this AI boom, and I view the bottleneck is the hardware because it takes longer than software engineers coding something or developing models or whatever that is. What kind of time? I mean, again, I don't want to put you on the spot, but when people hear this and they hear about AI and then we hear about hardware, people always go, the timelines are so different. And we kind of touched on that, but the timelines are different. I
Mm-hmm.
guess talk to us about that because if I'm a company and I want to produce something that's integral to this process, I am going to need time to put in software, but I need to build the building potentially to manufacture
Mm-hmm.
this. I need the machines to be made and delivered to me. I mean, talk to us a little bit about that.
Yeah. Well, first of all, I think that's right. Hardware does take longer to build than software for a few kind of like more physical reasons. That's very clear. That said, hardware development is accelerating because of software, right? Because we have these systems that can analyze data, it can help us build hardware much faster than before. And we could see that as an example of what Tesla and SpaceX have done. Take SpaceX as an example. Just about 15 years ago, this company was basically creating R&D versions of its rocket, and in a matter of 5 years, became the fifth entity outside of the first four entities, which were all nation states, to dock with the International Space Station. Now, fast forward here. I mean, the list is pretty unparalleled from being a modern kind of telecommunications provider with Starlink and the virtuous loop there, just how fast that has moved. So, upshot here is hardware is getting faster, powered by software. Interesting, software is now moving into AI, and AI, exactly to your point, has put a spotlight. It hasn't created the problem, but I think it's put a spotlight on this reliance on hardware. So we really, we talk about it today in 2025 in this like hardware versus software type of way. But if we really zoom out and look at it, it turns out that the cyber physical systems have actually just been converging. It's looked like a pendulum swing, but it turns out that it's actually two waves that have just been coming closer together. Software, to your point, has been historically and always will be delivered over hardware. It will be delivered over CPUs and data centers. right? And software will be used to power computers and cameras and cars, right? Now, all of a sudden, that software is using energy more. So now it's put a spotlight on energy. So that means that we need new types of nuclear reactors. I believe that nuclear power development is going to be accelerated by AI. So there's this virtuous loop. So it's all one, in my view. Just like the human body is not just a nervous system or a muscular system, right? Or a cardiovascular system. And these systems actually all play together. Sorry if I went out a little bit esoteric. I think that's exactly what hardware software is. And I'm very excited about the evolution in software and its convergence with hardware and the acceleration of hardware development to solve big problems in energy and compute powered by software, right? So the next 5, 10 years are going to be very exciting. You know, where I get optimistic and as examples here is as policy shifts with the CHIPS Act in particular has brought semiconductor manufacturing onshore. Examples of the TSMC factory in Arizona are, really good cause for optimism here. Because that factory bring up a lot of people doubted it. It only started a few years ago, but it is showing really good glimmers of possibility of moving TSMC outside of just Taiwan and bringing that technology, to the United States and then other places in the world, right? So keep an eye on that space and keep an eye on TSMC and what they're doing in Arizona. Keep an eye on what Micron is doing in New York. And I think, we're going to see a lot more of these stories pan out here from 26 to 2030.
Absolutely. I love that. Yeah, this has been a great episode. I think you covered a lot of ground for us. I'm sure I haven't asked all the questions someone out there is hoping I would have. But if somebody does have a follow-up question, they want to learn more, what's a good way of getting in touch with you?
Yeah, great. You can find me on LinkedIn, Karan Talati. Follow myself, follow First Resonance there. If you also want a broader perspective, follow me on X. My handle is also Karan Talati. You'll get a lot more takes beyond just what we do at First Resonance and dives into more takes on how AI converges with manufacturing and policy. So would love to connect there.
Absolutely. I appreciate the time, Karan. Thank you for sharing with us.
Thank you, Amir.
Absolutely. All right, that's it for this episode. Be back again, different guest, different topic. Until then, two things. One, talked a lot about manufacturing and hardware, and I think it's very relevant to everything we're hearing in the news about national security, about its need in the AI space. So we covered a lot of ground. So share this episode with somebody else that might benefit and find it of value. I'd appreciate that a lot. Also, like, subscribe, comment. Let me know how the show's going for you. Until next time, thank you and goodbye.